Okay, so with part C here now, right? They given us conditions, okay, for the population at a certain time. So n is 100, population is when t is 2, and then n is 160 when t is 12, right? So they're giving us conditions here, and that will help us to work out what k is, for instance, with part 1 here. They want us to show that k is 0.047. This, remember, now is like our formula, okay, for determining the size of the population. Okay, now if you couldn't get this out in part B, like I showed in the last video, if you couldn't do it, you can still have a go at part C, okay, because they're giving that to us, haven't they? So, you know, if you've lost marks there, you can still get the 7 marks here. And what you do is, the conditions they're giving us, just sub it in. So n is 100, t will be 2, yeah, so if I put 2 there, it'll be k times 2, which is 2k. And in the other situation, then n is 160, so put 160 in. When t is 12, so t is 12 there, that'll be 12k. Okay, so if I call these equations 1 and 2, I can now solve them simultaneously to work out k. And the best way to do that is just to do 2 divided by 1, okay, or divide them, right? That's the best way. Now, divide them, and the reason why I've said 2 divided by 1 is because if you look at number 2, it's got the highest power, right? That's a higher power than that. So if I divide them, let's look at the left-hand side, 2 divided by 1, well, that divided by that will just be 160 divided by 100. And if I look on the right-hand side, this divided by this will be ae to the power 12k over ae to the power 2k. And what you'll notice then is the a's will cancel. 160 divided by 100, okay, is actually simplifies down to be 8 over 5, right? And then, of course, when you take away these, you need to appreciate, it's just indices, isn't it? Rules of indices, and you just take away the powers, okay? There's rules of indices, right? You take away the powers when you divide, yes? So that would be 8/5 equals to e to the 10k. And then to get this here, of course, I can take e over the other side, right? And e becomes ln when I take it over, so I get that. And then, of course, to get k, I just got to divide then. K will be ln 8/5 divided by 10. So let's just check that that does come out on my calculator as they want, okay? And that comes out to be, yeah, 0.047. Let's just double check they wanted, yeah, 3 decimal places, okay? So then it says, right, find the size of the population when t is 20. When t is 20. Now, if you think about it now, right, if we go back to our formula, we've got n equals ae, but now I've got k, right? Now I've got k. I can substitute k in there to be 0.047t. Okay. Trouble is, right, if they want me to find the population when t is 20, well, I can't actually do it yet because I don't know what a is. Okay, I've worked out what k is, but I don't know what a is, right? So we need to work out what a is as well. Okay, but the good thing is I can actually sub this into like 1 or 2, couldn't I? So if I sub it into 1, okay, sub this into 1, I'll write it up here. I'll have 100 equals to a e to the 2k. Of course, k is 0.047, and then I can just get a then quite simply, couldn't I? Just by doing 100 divide by e to the power 2 times 0.047. Okay, so if I do that, where's my e button? E to the power 2 times 0.047. So I've got that there. I think I've typed that in right, and I've got 91.003. Right, 91.03. Rounded 2 decimal places. Well, perhaps I'll put 3 decimal places because k was rounded to 3 decimal places, wasn't it? So 91.028. That would make more sense. Okay, so then I could say, therefore, n is equal to 91.028 e to the 0.047t. Okay, and then when t is 20, which is what they wanted, n is equal to 91.028 e to the 0.047 times 20. And right, I get that. So basically 91.028 e to the power 20, 0.47, and I get that out to be 233. Okay, population, yeah, because it's the size of the population, I'm not going to put 0.029 whatever. Okay, obviously population can only be an integer value, okay, a positive integer, and that's the acceptable answer.